These are the notes for chapter 2.1 through 2.3. An inequality is a mathematical sentence that compares two things. So a math sentence that compares two things. And if it's comparing two things, it's either going to be greater than, less than, greater than or equal to, less than or equal to. Solution to the inequality, solution of an inequality is the answer. Or in other words, it is a number that makes the inequality true. When you have an open circle, that matches with a greater than or a less than sign, and that means that that number is not included. So if you have x is less than 5, it means it cannot equal 5. It could equal 4.99999, but it couldn't equal 5. Less than or equal to, greater than or equal to, that means that the number can equal 5. So x is greater than or equal to 3. I'm going to put a 3 right here on my number line. This is a closed circle. And notice that the big wide open side comes first. That means x is bigger than or equal to 3. And then we would color in everything to the right here. Next one, x is less than -1. Here's the -1, and then the number goes this way. And if you notice, if the variable is on the left-hand side, this arrow matches this arrow. If the variable is on the left-hand side, this arrow matches this arrow. Number 3, write an inequality that represents the graphs. These numbers are all bigger than 1, so the numbers, which I'm going to call x, are greater than 1. Since it's an open circle, we have a greater than sign. Another way you could write that, rather than saying x is bigger than 1, you could say 1 is smaller than x. Number 4, our boundary right here is 3, and these numbers are smaller than 3. And since the circle is closed, you also have the equal to sign. So those numbers are smaller than or equal to 3. Notice the teeny tiny small side means smaller than or less than. Or you could also say 3 is greater than or equal to x. Next one, determine whether the value is a solution to the inequality. If we put 19 in here, 19 minus 7 is 12. 12 is not less than 12, so that one is a no. That number is not a solution. And here, if we put the 1 in, 3 times 1 plus 6 is 9, bigger than or equal to 9. This time, since it has the equal to sign, that would be a yes. At the top of the next page, we need to graph and solve these. So we will add 3 to both sides, and that becomes x is smaller than -1. Sorry, I almost forgot that negative. So we're going to have an open circle on the -1, and x is smaller than, so we want everything to this side colored in. Number 8, first thing we need to do is combine these like terms. 4c minus 3c is just a c plus 10. From there, we subtract 10 from both sides, and you will have 2 is less than or equal to C. You could also write that as C is greater than or equal to 2. And I prefer to write it that way because then the variable is on the left-hand side, and then our arrow should match. 2 is smaller than these numbers, or these numbers are bigger than 2, so we want everything to that side colored in. Number 9, first thing we need to do is combine these like terms. Negative 7p plus 8p will be 15 plus p is less than 13. I subtracted 15 minus 2 is 13. Subtracting 15 from both sides, p is less than negative 2. We're going to have an open circle because it's a less than, and everything here to the left is colored in. Number 10, we divide both sides by 6. You have x is smaller than negative 5, so you're going to have an open circle on the negative 5, and everything this way colored in. Number 11, this one is a little bit different. See how we have this negative in front of the 4m? If you multiply or divide by a negative, you have to flip the sign. And I'm going to have us write that up here. If you multiply or divide by a negative, flip the sign. Very important. So number 11, we're going to divide both sides by the negative 4. Since we divided by a negative, we have to switch the sign around. Negative 16 divided by negative 4 is 4. Since it's an equal to, we will have a closed circle on the 4 and everything smaller than 4 colored in. Number 12, this is a negative 6, dividing by negative 6. So the opposite of that is multiplying both sides by a negative 6. Positive 6 and negative 6 cancel each other out. Since we multiplied by that negative, we have to switch the sign around. And 1 times negative 6 is negative 6. Divided by 3 is 2. So we will have an open circle on 2 and everything smaller than that colored in. Multiplied by a negative, so we had to switch the sign. Divided by a negative, so we had to switch the sign. 13, we want to get rid of this 3/7, so we multiply by a 7/3. Notice this is not a negative number. We multiplied both sides by negative thirds, or by 7/3, excuse me. So we do not have to flip the sign. 7 and the 7 will cancel each other out. And we have negative 6 over 3, which is negative 2. We did not flip the sign because we did not multiply or divide both sides by a negative. So this says negative 2 is smaller than f. If you want to write it so your variable is on the left-hand side, you can. We have a closed circle and then everything over here colored in. Number 14, trying to get rid of this negative 4, we are going to multiply both sides by a negative 1/4. I multiplied both sides by a negative, so I have to switch the sign around. Negative times a negative is a positive. That will be 2 over 12, which reduces to 1/6. And you can, rather than saying 1/6 is bigger than x, you can also say x is smaller than 1/6. You will have an open circle on 1/6 and everything this way colored in. 15 through 20, writing these sentences as an inequality. A number b is fewer than or smaller than 37. So b is less than 37. 12 is greater than or equal to. So we have the 12 greater than or equal to 5 times a number. That will be 5n. 1/3 of a number h. So 1/3 of h is less than 15. 7 is less than or equal to. So 7 is less than or equal to. Difference means we are subtracting. So the difference of a number q in 6 would be q minus 6. Sum of a number means we're adding. So u plus 14 is more than 6. So that's greater than 6. And 70 is at least twice the number k minus 4. Number 21, you have no more than $15 to spend on groceries. That's the highest number you can spend. You can spend all of your money, so that would be less than or equal to. You already have $8 worth of stuff in your cart, and you have some more, we'll call it X, that you can put in there. And if you subtract 8 from both sides, X is less than or equal to 7. And if you are asked to write a sentence, you would say you can spend up to $7. Number 22, there are at least 36 red and blue marbles in the bag. So this is the smallest possible number. 36 is the smallest it can be. So that number then has to be bigger than 36 because this is the smallest it can be. Red marbles is twice the number of blue. So red equals twice blue. So we're going to have twice blue plus the blue, and that compares to 36. This is the smallest it could be. So we would have 3b is greater than 36. And if we divide both sides by 3, don't need that b there, you would have b is greater than 12. So you would say there are more than, let's see, so we would have 12 blue and 24 red.